Hello, today we're going to go through the GCSE Physics Higher Tier Paper 1 from May 2018 and it's question number 7. As ever, take your own time, choose your own pace, press play and stop as you wish. Question 7. A student investigated how the pressure exerted by a gas varied with the volume of the gas. Figure 12 shows the equipment the student used. A pump was used to compress the gas in a tube. As the volume of the gas decreased, the pressure of the gas increased. 7.1. The student only recorded one set of results. Give 2 reasons why taking repeat readings could provide more accurate data. So as soon as you start taking repeat readings, what that allows you to do is calculate the mean average. And then as well, what you'll be able to do, if you've got results that are similar that you can compare against each other, you can then identify or remove any anomalous values. As a reminder, the anomalies are the odd ones out, the outliers. In question 7.2, figure 13 shows the position of the student's eye when taking volume measurements. Explain what type of error would be caused if the student's eye was not in line with the level of the liquid in the tube. Now, because you would attack the tube from different angles each time, there'd be no particular way of repeating what you've done previously. So we'd call that one a random error. There's no way of telling exactly how big or how small the error is. And the reason for that, the eye position would never be in the same place. For 7.3, if the gas is compressed too quickly, the temperature of the gas increases. Explain how the temperature increase would affect the pressure exerted by the gas. So anything that involves temperature means you're going to get a far greater movement. It will increase. And if it's moving faster, the molecules inside will then collide with the walls more often every single second. So therefore, the pressure in the tube would increase. There are more collisions per second. And the reason for that, the higher temperature means they have a higher kinetic energy, which of course links directly to the idea about movement. If it's moving faster, it will have a higher speed, so it will have a higher kinetic energy. For 7.4, one of the students' results is given below. Calculate the volume of the gas when the pressure was 1.8 times 10 to the 5 Pascal. The temperature of the gas was constant. Now, this is worth 3 marks, and there's a couple of steps to take. The first one is to remember that pressure times volume equals a number. It's not a fixed constant, but it's a constant based on the numbers that you've got. So in the first instance, the pressure is 1.6 times 10 to the power of 5, and our volume is 9 centimetres. Now, because it's a constant, the units in this case don't matter, so you don't need to change the fact that it's centimetres cubed into metres cubed, as long as you're consistent all the way through. Notice the volume here is centimetres cubed, so no change is required. So put that into a calculator, 1.6 times 10 to the 5 times 9, and that gives you 1.44 times 10 to the power of 6. The next step is to realise that, well, that was P1 and V1, 1, and now we've got another pressure, and we've got a second volume. So we can now say P2, V2 equals a constant. And because it's the same system, it's the same constant. So P2, V2 equals 1.44 times 10 to the power of 6. We're given P2, which is 1.8 times 10 to the 5, and then we're trying to find V2. So V2 is 1.44 times 10 to the 6 divided by 1.8 times 10 to the 5, and that gives a value of V2 of 8.0. Finally, 7.5, figure 14 shows a person using a bicycle pump to inflate a tyre. The internal energy of the air increases as the tyre is inflated. Explain why. So the first thing to realise is the person is doing work. They're continually moving the piston up and down. And as soon as you do work, you always end up with energy wasted as heat. And actually, last time you pumped up a bike, if you touched certainly that part just here, then you'd know that it's very warm and can actually hurt. So the internal energy of the air increases. Explain why. So the first mark is to say work is done on the air, and then that means the temperature increases. Not that you need to explicitly say it for this question, but internal energy is the potential energy plus the kinetic energy. So potential energy is the energy trapped between bonds, and kinetic energy is how fast the molecules or particles are moving. So because you're doing work, you're making them hotter, they're therefore moving faster, or they've got a high kinetic energy. If they've got a high kinetic energy, then overall the internal energy will increase. You're now at the end of question 7. Any questions, as ever, please get back to me.